Okay, so far what we've done is we've graphed our height in centimeters on the y-axis. We decided to count by tens because our highest number is 185. So if I divide that by 20, it gave me around 9. But no one wants to count by nines. We're counting by tens. Then on the x-axis, we have our height in inches. We decided to count by 5 because our highest number is 73. And 73 divided by 20 was around 3.5. But 5 makes more sense to count by. You then needed to plot your points, which should have come out to a straight line, and used your ruler to make the line. We gave it a title of height in centimeters versus height in inches. And if you had forgotten, you can put that on your card, that the title should always be y versus x. Should this go through 0? It really depends on what it's a graph of. In this case, this is a graph of height in centimeters and height in inches. So if I was to measure this paper, you can't have a height on one side and not the other, right? If it has a height, it has a height in both centimeters and inches. So it makes sense for this to pass through 0, 0, because you can't have centimeters without inches. If it has a height always. Okay? On the back, I'm going to end up picking 2 points. Those are the 2 points I've circled here. You could have picked any 2 points on your line. I'm just going to use these 2 for the example. So your numbers don't have to be exact, but they should be similar because you picked 2 points on your line. The answer to number 1, what is your scale counting by, I just discussed. So you should have that written down, something like on the y-axis it's counting by 20, on the x-axis it's counting by 5, or sorry, by 10 and by 5, because you wanted to fit those numbers on there. Yes?
So do you give this to you after the period or can you
Oh, no, this is yours. So the self-test you always get to keep and take home and study from. Yep. Okay. On number 2, it says to calculate our slope. So the base equation for slope is rise over run. So we're trying to figure out how much are we going up, over, up, over, up, over, okay? But we're going to use 2 points that are far away from each other. That way it gives a better picture of our line. So the 2 points that I picked, again, were these 2. So I would call this my x1, y1, and this one my x2, y2. The one that's farther down, I would call this my x1, y1, and the one that's farther up, the x2, y2. Okay? So you're subtracting the smaller one from the bigger one. So 185.5 minus 58.5. Don't forget units. On the y-axis is our centimeters, divided by what's on our x-axis, which for me was 73 minus 23 inches. So now when you do that math, I'm going to subtract the top 2, and that gives me, oh, I didn't actually write it down, 127 centimeters, divided by, on the bottom, 50 centimeters. This is actually going to be 4 significant figures. Notice there's 5 significant figures here, 4 here, 4 here, and 4 here. So in this answer, I can keep 4, 2 decimal, oh, I can actually keep 2 decimal places. And here I can keep 4 because I'm subtracting. Yes, Carly. Thank you. Thank you. Okay, so now when I divide that out, I'm going to have 127 divided by 50. There's 5 significant figures and 4 significant figures, so I can actually keep 4. So this should be 2.540 centimeters per inch. So if you only kept 2, I would have given you the correct answer for, like, yes, you can calculate slope, but then you would have gotten only a 1 out of 2 for not using significant figures. Yes, George?
So in this situation, the 2.5, would it work, or?
So I would accept 2.5 in the fact that you know how to calculate slope, and I'd give you points for that, but then I would not give you full points for knowing how to use significant figures.
So I have
2.540. Or you have to have 4 numbers. Okay. Oh, okay. Well, then if it's consistent with the numbers you have, yes, that's fine. Nick. Yes. Right. Okay. Nick's question was, if you do this wrong, now the rest of the problems are wrong. But if you are plugging this into the right spot every time, and that's the only mistake you made, I'm not going to count that as if you don't know how to do this. Good question. So the units of slope, they did not cancel, so this should be centimeters per inch, because they don't cancel. If they cancel, they'd be the same. Like centimeter per centimeter would be nothing, yeah. In our sentence, for every 1 inch, there are blank centimeters. Well, that answer is right here. This is 2.540 centimeters per 1 inch is what that means. So you just needed to rewrite that number here. That was it. That number goes there. Where does your best fit line cross the axes? That's called your y-intercept. We discussed that a second ago. It has to be, that was on this one. It has to be through 0, 0, because you can't have a height in centimeter and not a height in inches. So this is 0, 0, because you can't have a height in centimeters and not in inches. Okay, so number 6 then has us write the equation of the line in slope-intercept form. This would be something to put on your card, is what do these mean? So the y is your y-axis equals m, which is your slope, times x, which is the x-axis, plus b, which is your y-intercept. Okay, so if you had forgotten those, that's what they each stand for. Y is just y-axis, m is slope, x is the x-axis, and b is the y-intercept. So an equation for our line, we know that if we want to find anything on the y-axis, we can take our slope, which is 2.540 centimeters per inch, and multiply it by what's on the x-axis, plus our y-intercept, which for us came out to be 0 centimeters. If you didn't put the plus 0 centimeters, it's okay, because it's 0. Okay, but if you did put 0, then they're both correct, with or without it, because it's 0. Yeah.
How did you get 0 centimeters?
Because we said that our y-intercept was 0 here, and so the answer you put here will be what you plug in for b. So this is b. Okay. So now it says to rewrite the equation using our meaning. So on our y-axis is height in centimeters equals 2.540 centimeters per inch times our height in inches. Okay? We don't have a b, so we can leave that off. Question on 7. Okay, now 8 says using your equation of the line, that's right here, this is the equation we're going to use, we're going to determine how tall a 70 centimeter person is in inches. Okay, so the first step is to write down your equation. I'm going to write height in centimeters, HCM equals 2.540 centimeters per inch. Make sure you always rewrite the unit. This number has units. Times height in inches. Okay. So we know our 70 centimeters, so that goes here. And this is what we're trying to find. So this is our height in inches. That's what we're trying to find. So I'm going to have 70 centimeters equals 2.540 centimeters per inch times height in inches. And this is what I'm trying to find. Okay. If I'm multiplying by that thing, I need to get it by itself. So I would divide both sides by this number. Don't forget to bring your units, because what happens is all of this cancels, and on this side, centimeters divided by centimeters cancels, but you're left with inches, which is what you want, because you want height in inches. So 70.00 divided by 2.540 means that my height in inches is 27.6. Uh-oh. Oh, nope, don't round. 27.56. Okay? Let me write that bigger. So it's 27.56. I know to keep 4 numbers. No, I shouldn't. Yes, I should. Sorry. There's 4 numbers here, and there's 4 numbers here, right? So I have 4 significant figures, so I can keep 4 significant figures.
If you, okay, so you divide it by
Yep. Yep. Okay, and the last one, number 9. It's similar. We're looking for this really tall man's height in feet if he's 2.72 meters. And we know from last unit that 1 meter is 100 centimeters. So if you've forgotten the metrics, I would add those to your card. And then 12 inches is a foot. Okay. So before I can use my equation, I need to get things into centimeters. So let's write our equation down. Okay, so height in centimeters equals 2.50 centimeters per inch times height in inches. I have to be in centimeters. You can't plug the meters in here. So I have 2.72 meters times, for every 1 meter is 100 centimeters. So meters cancel, and I have 272 centimeters. And then on this side, I can plug that in. So I have 272 centimeters equals 2.540 centimeters per inch times height in inches. Yes, Dylan? Yep, at the end of this period. So now, again, so Hazel, your question like last time was if I just divided it by the same thing. So that's what's happening here as well. I'm multiplying by here. So the opposite of multiplying, if I want to get this by itself, would be to divide. So I'm dividing both sides by this. Okay, so now this cancels, because all of that is just over itself. Now on this side, my centimeters cancel, and I'm left in inches. So 272 divided by 2.540 gives me 107.1 inches. So I would be done, but it wants it in feet. So the last step is to do your conversion into feet. So don't try to do some other math, just use dimensional analysis. There's 12 inches in 1 foot. Alright, so I set it up so inches cancel. And I have 107.1 divided by 12, which gives me 8.92 feet. There's 3 significant figures here, so I can keep 3 here at the end. So this guy is really tall.